Yeah, in this problem find the voltage V. It is a single source problem. Any single source problem normally we can easily solve using voltage division or current division or series parallel equivalent concept. If you observe this circuit carefully, this path is short circuited. This is parallel with 30 ohm. When there is a resistor parallel with the short circuit, the equivalent becomes 0. So in that sense, this 30 parallel with the short circuit equivalent of 0 ohm. So that will cancel. This 30 ohm drawn as it is, this circuit drawn as it is. Then again if you redraw this circuit, it will become like this. This 30 ohm can be shifted here. So that is coming here. This is as it is, this 30 ohm as it is. Then again further we can simplify this 30 ohm, this 30 ohm connected in parallel, equivalent of 15 ohms. Then this is 10 volts, this is 10 ohm, voltage V. Then this 15 ohm, 10 ohm connected in series across 10 volts. So V is equal to, using voltage division formula, 10 into this 10 divided by 10 plus 15, 25. But one important precaution in this is, this V polarity, this side positive, this side negative. Actually current flowing like this. Current is flowing like this, then this side it become positive, this side negative. But the question asked is V, this side positive, this side negative, so therefore it become minus. And this is simplified to minus 4. Answer. Yeah, in this problem, a bulb problem, the bulb specification given is 60 watt to 30 volts. Any electrical appliance, it can be bulb or a fan or any electrical or electronic appliance, that is designed at rated voltage of, Indian rated voltage of 230. What is the meaning of this? If we apply 230 volts, this bulb would definitely consume 60 watts. Such type of bulb, what is the voltage applied is 200. Now what is the power dissipation in this bulb? That is the problem. To find this, first what is the bulb resistance? The power is equal to V square by R. What is the power of the bulb given? 60 watts. What is the rated voltage? 230. 230 square divided by this bulb resistance R60. So from this R60 is equal to 230 square by 60 ohms. So with the help of this specification we find out 60 watt bulb resistance. Now what is the voltage applied? 200. What is the new power? Now power at this moment, power is P is equal to V square. What is V applied? 230. Not 230, it is 200. 200 square. V square by R. What is the bulb resistance? Is 230 square by 60. And simplify this one, you will get answer as 45.36 watts. So bulb is designed at 230 volts. Because we are applying less voltage, 200 less than 230, so power consumption is reduced to 45.36, which is less than 60. further if you keep on reduce the applied voltage, power dissipation will be reducing. Okay. In this problem, for what value of R1 maximum power is dissipated in R2? If you see most of the local books, the cases are very simple, but this is something different. For what value of R1 maximum power is dissipated in R2? For example, if R1 is equal to 0, if this is 0 means it is short circuit. If it is short circuit, nothing will flow through R2. So power dissipation in R2 becomes 0, but we want maximum. Maximum is possible, maximum power is dissipated in this, which is possible when more current is flowing. Highest current should flow. Highest current will flow through R2 only if R1 equal to infinite. Infinite means open. When this is open, whole current will pass through R2. Therefore, if R1 is equal to infinite, maximum current will pass through R2, maximum power is dissipated in R2. Okay. In this problem, we need to find RAB, but its length is infinite. This transmission line going up to infinite. Any infinite length of any transmission line, to find RAB, we cannot use series parallel. If we use series parallel, then we have to start at infinite, keep on simplifying series parallel. By the time we come here, we die. So it takes infinite time. Sometimes we can also convert, these three will form a star, convert into delta, again next to star into delta, star into delta. So many number of times we have to convert stars into delta. That also take infinite time. Even if we use current division, we need to go for so many number of equations. That also will take lot of time. The best idea is characteristic resistance concept we are using. What is the meaning is this circuit we can redraw symmetrically. So this 20, this 10 as it is, this 40 can be split into two resistors, each one 20. Then this 10 as it is. Next to 40 ohm also split into two resistors, each one 20 ohm. Like that it is extended to infinite, going up to infinite. Then you observe carefully 20, 20, 10. This will form one T network. Next to 20, 20, 10, this will form another T network. 20, 20, 10, this will form another T network. Whatever you observe in this section, that is getting repeated. So what is the concept of characteristic resistance is, when we take a infinite length of wire, whatever resistance you get here, that is R0, you travel for 1 kilometer, again you measure, its value will be same. Wherever you measure, its value will be same. Here also value will be same. That is the character of characteristic resistance. This principle can be applied here. So this section is getting repeated. Now break up here. Then if you measure this resistance is also RAB. Why this resistance also RAB, which is same as this? What is the length of this transmission line is infinite. In the infinite length, once we cut down this small piece, what is the remaining length is also infinite. Therefore this value is also RAB, this value is also RAB. Keeping this in mind, this 20 ohm, this 10 ohm, this 20 as it is, then this resistance is equal to RAB, which is same as this only. Now this is RAB. What is the resistance here also? Again RAB. Now make use of series parallel property. Therefore, RAB is equal to, this RAB is equal to, these two are series, parallel, then series. So 20 plus 10 parallel with 20 plus RAB. And this equation can be solved for RAB. So RAB answer is 2A. Is the RAB or R equivalent? Yeah. In this, for what value of A, maximum power is transferred to load, that is 20 ohm. Whenever to apply maximum power transfer theorem, it should be like this. This is Vs, this is Rs, then load contain RL. RL is variable. So this is the standard form we use for understanding maximum power transfer theorem. When you get a maximum power, if RL is equal to Rs. But this problem is not appearing like this. So first thing is we have to replace this with the Thevenin equivalent. Using Thevenin's theorem, first to open here. If you open terminals here, what is the open circuit voltage? 20 volts divide equally, 10 ohm, 10 ohm. So equally divide. It become 10 volts. That is VOC or V Thevenin, 10 volts. Then what is R Thevenin? When voltage source is short, 10, 10 become parallel, equivalent of 5 ohms. 10, 10 parallel, it become 5 ohm. So this is the Thevenin equivalent of this particular circuit. Next, here load contain RL, but here this circuit is not appearing like this. There is also another important property we should know. What is this one? Is a transformer. Is a transformer. You should know transformer related formulas. When secondary is loaded with load of 20 ohms, that is RL of 20 ohms, the primary equivalent become 20 divided by A by 1 square. So it is equivalent to 20 by A square. When secondary loaded with 20 ohm, turns ratio is 1:A. The primary equivalent formula is RL by this turns ratio A by 1, so A square. 20 by A square will reflect at the primary of the transformer. So what is the resistance here? Equivalent is 20 by A square. So in place of RL, now I got 20 by A square. To transfer the maximum power, 20 by A square should be equal to 5 ohm. So 20 by A square is equal to 5 ohm. Solve for A. Solve for A. You will get A equal to 2. Once A is known, 2, A square become 4. 20 by 4 is 5 ohm. So 5 ohm satisfied, maximum power is transferred. And also what is the maximum power transferred? There is a directly formula. Maximum power transferred is Vs square by 4 into RL. We can use RL or we can also use RS. This comes under case 1. In case 1, Vs square by 4 into RL or 4 into RS also we can take it. What is Vs source voltage? 10. Square by 4 into either RL or RS, anything we can take, which is 5. This answer is 100 by 20, 5 watts. Answer. In this problem, total energy stored in the circuit. Which element will store the energy? Inductor will store energy. Capacitor also store energy. All other resistors only dissipate the energy. So as per the question, total energy stored. We should consider energy stored in inductor plus energy stored in capacitor. We also know that for DC in steady state, inductor behave like a short circuit element. Capacitor behave like a open circuit element. Inductor will be short, capacitor is open in the steady state for a DC signal. So what is applied is a DC current source. Inductor is simply short circuit, capacitor is open circuit. What we need in this current? What we need in this voltage? Why voltage is needed? Energy depends on voltage. Energy in inductor depends on current. So we have to find the current in this and voltage in this capacitor. It is a normal, simple resistive network. Think of how to find this current, how to find this voltage. Now if you observe this one, this circuit carefully, this path is open. What is the current here? 10 amps. 10 ampere current entering. After 10 ohm resistor also current is same. Current is same. This current to 10 ampere divide between 20 ohm and 30 ohm. Using current division formula, this current I is equal to incoming current is 10, then opposite branch resistance 20 by 20 plus 30, 50. So this is equal to 5 1 ja 5 2, it is 4 amps. Current through inductor is 4 amps. Then voltage in capacitor. Voltage across capacitor, how to find? To find voltage across capacitor, start at positive, go to negative, following KVL sign convention. So when we go like this, 10 into 10. 10 into 10 is equal to 100 volts. And current is going downward, we are also going same direction. As per the KVL sign convention, both are same means it is positive. So capacitor charged to 100 volts. Next we want total energy stored. This total equal to energy stored in inductor plus energy stored in capacitor. Energy stored in inductor is half into L into I square plus half into C into V square. Half into L. L value is 1 Henry. Current of 4 square plus half into C is 1 farad and voltage across capacitor is 100 square. So simplify this. The answer will be approximately 5 kilojoules. That is the answer. Yeah, in this problem, there are three sources are there. Current source I1, another current source I2, third source voltage source V3. Then this current depends on this current source, and this voltage source. So there is a relation given already. This I depends on A times of I1, B times of I2, C times of V3 as per the superposition principle. We need to find ABC. So many ways this problem can be solved. One intelligent way of solving, a bright IIT student can solve like this. Imagine this voltage source not there, short circuit, this is open circuit. Open and short, this is there. So it looks like 10-10 series. parallel with 10, use current division, directly you can get this current I in terms of I1. So directly you will get A. Second case, current source open, this current source open, then only take this. Current is flowing, so this current is nothing but source by 10 plus 10 plus 10. Then you will get to C. Similarly, keep I2 and this is short, this is open, then find current, then you will get V. This is the fast way of doing. IIT student, more IQ student can solve like this. Average student can solve like this. Convert this current source into voltage source. It become like this. Current arrow down. So source is like this. I1 into 10. So 10 I1. Then we are converting current into voltage source. So this 10 is series. Then this 10 as it is. This voltage source as it is, V3. Then convert this current source into voltage source. Again this is 10 ohm, 10 into I2. This is 10 I2. It become a single loop. Now we can go for a loop equation. What is the loop equation is 10 I1. Now assuming this current is I, so this current is I. Then we are going this side, this is our choice, any fashion we can go. If we go like this, then this become minus 10 I1 plus 10 I, then minus 10 I2 plus 10 I minus V3 plus 10 I is equal to 0. Now solve for I. Solve for I, it will come 1 by 3 I1 plus 1 by 3 I2 plus 1 by 30 V3. So I1 coefficient is A equal to 1 by 3. I2 coefficient is B is equal to 1 by 3. V3 coefficient is C equal to 1 by 30. So this is answer. You can also solve like this. You can also solve previous method. Both are correct. Yeah, in this circuit we need to find VA. What is the meaning of VA is voltage at this node with respect to ground. Ground already given in the circuit. So we have to find voltage here with respect to ground, this ground only. This problem can be solved using nodal analysis and also mesh analysis. Since question is to find voltage, nodal analysis is preferred. Then this circuit can be simplified further. 5 ohm, 2 ohm, 3 ohm connected in series. So 5 plus 2, 7, 7 plus 3, 10. It is simply 10 ohm. Then this 10 volts as it is. Current source as it is. Then 4 ohm, 2 ohm both are connected in series. This also 6 ohm. Voltage of 6 volts as it is. This ground as it is. This voltage VA also as it is. Now we can solve easily using nodal analysis. If you consider this as a node, we can assume all currents are leaving. Not compulsory, but I am assuming all currents are leaving. Sum of the currents leaving from this node is equal to 0 as per the current law. So what is this current now? VA minus 10 by 10. This is the current leaving. Then this downward current already 2 ampere going out, plus this current is VA minus 6 by 6 is equal to 0, because sum of the currents leaving from the node is equal to 0. This equation can be solved easily for VA. So solve this equation for VA, you will get answer 0. In this problem, a current source is connected to capacitor, single current source, single capacitor, but current source is not a DC current source, but that is described using this function ut plus 2 minus ut minus 2. So this function is existing from, if you draw the plot for this, it will start from minus 2 to plus 2. Minus 2 plus 2, this value is 1. This is time. This is current I. So current of 1 ampere is coming over a duration of minus 2 to plus 2 only. You know how to draw the graph of ut, then ut plus 2, then draw the graph of ut minus 2, take the minus sign, then add, you will get this. So if you know right shift to left shift to those concepts, then you can understand how to get this graph for this function. So finally, this current is giving 1 ampere from minus 2 to plus 2 duration only. What is the question asking? Charge in capacitor at t equal to 0. T equal to 0 is this. Minus 2 to 0, current of 1 ampere flowing. What is the charge? What is the charge formula? Charge is nothing but current into time. Current into time. But how much current flowing? 1 ampere. How much duration this current is flowing? Minus 2 to 0, the time gap of 2. Therefore, it is equal to 2. It is a charge 2 coulombs. So 2 coulombs of charge. I am using this formula current into time because current is constant. If current is changing with time, if you multiply, you will get wrong answer. In that case, you need to go for integration. Here also we can go for integration, but I am not using integration because current is constant. Simple multiplication will give same answer. Next, coming to energy in capacitor. Energy in capacitor formula is half CV square. As per the formula, half into C is given 1. Then what is voltage in capacitor at t equal to 4 seconds? At t equal to 4 is coming somewhere here. But capacitor is charging minus 2 to plus 2, nothing is charged here. Whatever voltage is there at t equal to plus 2, same voltage retain even at t equal to 4 also. Therefore, we need to find voltage at t equal to plus 2 that can be taken as it is even at t equal to 4 also. Therefore, voltage in capacitor Vc of t The formula is 1 by C, C is 1, integral, general formula minus infinite to t, but current is flowing from minus 2 to plus 2. So directly I take it from minus 2 to plus 2, current of 1 dt. Then if you integration of 1 is t, limits from minus 2 to plus 2. So it is 2 minus of minus 2, it becomes 4 volts. At t equal to plus 2, capacitor is having voltage of 4 volts. At t equal to 4 also same voltage, it remains same. Now substitute this 4 here, 4 square. 4 square 16, 16 by 2, 8 joules. This is the energy in capacitor, this is the charge in capacitor t equal to 0. Yeah, in this problem what is given is current I given as 2 amps. With this current of 2 amps, what is the voltage of V? That is the question. So since current to 2 ampere given, this is 2 ampere current given, what is the voltage here? 2 into 0.5, 1 volt. 2 into 0.5, 1 volt. Then this 2 ampere current is dividing 1 ohm, 1 ohm. So obviously equally divide 1 ampere in this, 1 ampere in this. Then what is the voltage here will be 1 ampere into 1 volt. As per the fundamental property, voltage to find the voltage here, start here, go to ground. This voltage is 1 volt, this voltage also 1 volt. 1 plus 1 is equal to 2 volts. So what is the value of V now? 2 volts. Over. So this problem is based on phase difference between two different functions. Whenever they ask phase difference between two functions, the first important is see that both the functions are in same form. Both can be sine or both can be cos. The second condition is see that both the amplitudes are positive or both the amplitudes are negative. But in this problem, this is a cos function, this is sine. This is positive, this is negative. Change negative into positive or positive into negative. Then change cos into sine or change sine into cos. When both are in same form, then go for the difference, it will give the correct answer. This is the standard normal procedure. Keeping that in mind, we know this formula, cos 180 plus or minus theta equal to minus cos theta. This minus cos theta form changed into positive form using this formula. Therefore, this is equal to plus 10 cos 180 plus theta I have taken. We can also take minus theta, answer will be same. So 10 cos 10t, 180 plus 30 become 210. Now this negative changed into positive, but this is cos form, this is sine form. Cos also changed into sine form. To change cos function into sine, add another 90 degrees. So it will become this. So amplitude is positive, function is also sine form. Second function I2 already positive and this is in sine form. Now what is the question? I1 leads I2 by how much? Because I1 leads I2 by how much? So I1 angle is 300, I2 angle is minus 60, difference equal to 360 which is equal to 0 degree. Even if they ask a question, I2 lags I1 by what? Again answer will be same. So I1 leads I2 or I2 lags I1 Question is a different way of asking, but answer will be same. Yeah. So this is the standard procedure. Most of the problems we can solve easily. The same problem also can be solved with the help of phasor diagram. So when we are taking a phasor diagram, you can take sine reference or a cos reference. Then you know the fundamentals like a 3 of angle 30 degrees. How to show 3 of angle 30 degrees? Length 3 angle plus 30. Plus 30 means counterclockwise direction. This angle 30, this length 3. If it is 3 of minus 30, then this angle will be minus 30, this length is 3. So these things you know in the trigonometric part of intermediate. Using this concept also, you plot these graphs, then take the difference, you will get the same. That is also another approach. So in this problem, AC voltage source is applied to RL series circuit. Find complex power supplied by source. To answer this one, first find inductive reactance, that is J omega L. J into omega is 10, L is 0.4, so it is 4 J ohms. Then total impedance Z is 3 plus J4. Then phasor current I, this phasor voltage is 20 by root 2 at an angle of 30 degrees. This 20 by root 2 is RMS. Compulsory we should take RMS only because we are dealing with the power. So 20 by root 2 at an angle of 30 degrees. This is the phasor form equivalent of the voltage source. Similarly, the phasor current I is equal to voltage by impedance. Voltage is 20 by root 2 at an angle of 30 divided by 3 plus J4. This 3 plus J4 is equal to 5 of angle 53.14. which is equal to 4 by root 2 angle of minus 23.14. This is current. Now with the help of voltage and impedance, we got the current in phasor form. What is the question? Complex power supplied. This complex power is represented with S. This S has got 4 formulas. It can be V square by Z or I square Z or Vi star or P plus JQ. But since question is power supplied by source, you can't use V square by Z. Only one option left is Vi star. This is one of the formula. Out of 4, this formula only applicable because we want complex power supplied by source. This small v indicates voltage with angle. The small current also indicates current with angle, Vi star. So what is the V is 20 by root 2 angle of 30. Then current we need to take in terms of complex conjugate. The star indicates complex conjugate. 4 by root 2. When we go for a complex conjugate, this angle change. Minus become plus, so 23.14. Then this can be simplified easily. This answer is 24 plus J 32. Units are volt ampere. We need not convert in complex form. We can also keep it in polar form. The advantage if we convert into this form, it will give P value and also Q value. P is the average power, Q is the reactive power. But this need not be in complex form, it can be in polar form also. Over. Yeah, in this problem, for what value of Vs, maximum power is transferred to load. This problem comes under maximum power transfer theorem. It is a special case because load contain a voltage source. For what value of this Vs, maximum power is transferred to load. But if you observe carefully, the source is not in Thevenin equivalent form. So first replace this with Thevenin equivalent. Open circuit voltage 1 ampere into 100, that is 100 volts. Then when we are finding R Thevenin looking from this, current source is open, this path is open, so R Thevenin is simply 100 ohm. That is series with the voltage source. Now connect the load as it is. This is variable source Vs, 50 ohm, 200 ohm. Now load is connected across these two terminals. As per the maximum power transfer theorem, maximum power is transferred to load if load resistance is equal to source resistance. When source is 100 ohm, load resistance also should be 100 ohm. If this is 100, this is 100, when 100 volts are applied, this voltage divide equally. This voltage of 50 volts, then this voltage also 50 volts. If this voltage is 50, obviously voltage at this node is also 50. Then comfortably we can write nodal equation at this node. Assuming this current is entering, this current leaving, this current leaving. So what is the current entering? 50 by 100. 50 by 100 is the current entering, is equal to sum of the currents leaving. This current is 50 by 200 plus this current is 50 minus Vs by 50 ohm. So one unknown, one equation sufficient to solve for Vs.